Okay, so the key with these differential equations is your variables have to agree on each side of the equation. Variables need to agree, and you'll see what I mean here in a second, on both sides of the equation. If there are any constants, they go with the x. Your variables need to agree on both sides of the equation. Your constants go / stay. If they're already with the x, like in the first example there, that plus 3 is going to stay on the side with the x. All right, now, I don't have it expressed as dy over dx there just because of the way I had to type it into the computer. But just remember that that dx is in the denominator. So your first step is to make sure that your variables are all on the same side. So over here on the right side, we've got x. So this dx needs to be on the same side as the x. Well, we're dividing by dx, so it makes sense that we multiply by dx. So we have this expression times dx. We're trying to solve this differential equation, meaning we are trying to get y equals. Right now we've got dy. Well, dy is the derivative, so the opposite of the derivative is to take the integral, or the antiderivative. So I know there's nothing truly on the left side. Just remember that technically there's a 1 there, right? The antiderivative of 1 would be the variable. We're used to it being x, but this time on the left side, we're integrating with respect to y, so we're going to put a y there. I know this is indefinite integration. We're not going to put a plus c on the y side. We'll put the plus c on the x side, okay? The antiderivative of x plus 3 would be x squared over 2 plus 3x. And like I said, we'll put the c over there on that side. And that's it. That has solved that differential equation. If we took the derivative of that equation with respect to x, we would get x plus 3. Now, we're going to look at some examples here in a minute where y is not going to be by itself over here on the left side, so we're going to have to do some manipulation after that point. But right now, for this example, we're done. That's the answer. Okay? That is the solution to that differential equation. Now, if they had given us some kind of initial condition, if they had said that x is 2 and y is 5, then we could solve for c. But we'll look at an example like that in a minute. All right, let's change this example just slightly. Let's change that x into a y. So we've got dy over dx is equal to y plus 3. We need the variables to agree on each side. So on the left side, we've got y and x. On the right side, we have y. So here's what we're going to do. We're going to do what we did on the last problem. We're going to start by moving that dx, but the problem with that is that we don't have x's on that side. Right now we've got y on that side. So we need to move that y expression to the left side. Now, you can't add or subtract. Okay, if we add or subtract, then we're going to get like dy minus y. That's not going to allow us to integrate. So y plus 3 is being multiplied by the dx, so we've got to divide by the y plus 3. So let me write it this way, though. 1 over y plus 3 dy is equal to y plus 3 divided by y plus 3 is 1. Usually we don't write that 1, but we're getting ready to integrate, so it's helpful to see that expression there. So like I said, we're going to integrate. Now, on the left side, that's not a power rule. That's 1 over y plus 3. 1 over, we should be thinking natural log. Now, We don't have to do u substitution in this situation because the derivative of what's on the inside is 1. But if for some reason that was 2y or something like that, we need to look at it from a u substitution problem, or even if it was negative y, because the derivative of that would be something other than 1, you would have to look at it as a u substitution problem. The antiderivative of 1 with respect to x is an x, and like I said, we're always going to put the plus c on that side with the x. Now, solving the differential equation, we really need to get y by itself. Right now, y is inside that natural log. So to get the y out of the natural log, we need to put this in exponential form. The base of the natural log is e. Remember back to pre-calc, exponential form, we do the swoop. Okay, e to the x plus c is equal to y plus 3. At this point, we can drop the absolute value bars because e raised to a power is always going to be positive. Okay, e raised to a power is always going to be positive, so we don't need the absolute value bars anymore. We're trying to solve for y, so we'll subtract the 3 from both sides. So we have e to the x plus c minus 3 is equal to y. We're almost finished. There's one more thing that we do with these problems when we have e raised to that power. We're going to use the properties of exponents to kind of go backwards. The properties of exponents say when you multiply like bases, you add their exponents. So we're adding something in the exponents, so we're going to go backwards. We're going to write that as e to the x times e to the c. Okay, we're just using that property in reverse order. When you multiply like bases, you add their exponents. So if we started with the green line, we would combine those two bases of e to end up with the blue line. The reason why we do that is because e is a constant. So e raised to c, c is a constant, that's just another constant. So our final answer here is we're just going to consider this to be another c, so we'll call it c sub 1, times e to the x minus 3 is equal to y. E to the c is another constant, so we just put that in front of the e to the x expression. Okay, so a lot of stuff changed by changing one variable. We changed that x into a y, and our answer, our process had several more steps, and our answer looked very, very different from the answer in the first problem. All right, here's another one. Y prime, I'll just remember y prime is the same thing as dy over dx, is equal to the square root of x times y. So we're going to do the same thing. We need our variables to be the same thing on each side. So the dx moves to the right, the y moves to the left. We had to divide by the y, so we've got 1 over y. I'm going to go ahead and write that square root of x as x to the 1/2 because I know I'm going to have to apply my power rule. Are we okay where that line came from? Do I need to show more work with that? Okay, the y was over here. We need to move it to the left, so we divide by it. The dx is on the left side, so we multiply by it. Integrate both sides. 1 over y is the natural log of y. Technically, we do need absolute value bars right now because just plain y can have a negative value. You can't take the natural log of a negative number. On the right side, x to the 1/2, add 1, we get 3/2, so multiply by the reciprocal, 2/3 x to the 3/2 plus c. Okay, same thing as the last problem. When we have that natural log, we want to put it in exponential form. So we have e to the 2/3 x to the 3/2, we've got a lot in that exponent, plus c is equal to y. Again, at this point, you can drop the absolute value bars because e to a number is always positive. And we'll do the same thing that we did in the last problem. Decomposing that exponential, you can just know that that automatically puts a constant in front of the e. If you want to show the steps, you can, but that's the way it happens every single time. So you can kind of just go ahead and jump to that when you see that you're adding that plus c in the exponent of the e to the power. Any questions about those three examples? All right, let's look at another one. Similar kind of scenario. Y prime is equal to 2x over y. Y prime is equal to 2x over y. If you want to write that from the get-go as dy over dx, that's fine. Just realize sometimes it'll be y prime, sometimes it'll be dy over dx. You just got to recognize that those are the same thing. Now, the good thing about this problem is that when we move things, we don't end up with 1 over y. Because right now, y is in the denominator, so when we move it, we multiply by it. So we get y dy is equal to 2x dx. Integrate both sides. The antiderivative of y would be y squared over 2. The antiderivative of 2x would be x squared plus c. We need to solve for y. So we want to multiply both sides by 2. Y squared is equal to 2x squared plus, we'll just call that a c sub 1. Because technically it's a different constant, but it's still a constant. And then we need to take the square root. Now, when we take the square root, we must remember the positive and the negative. Okay, when you take the square root, you must remember the positive and the negative. Now, which one it's going to be depends on if they give us an initial condition. So we're going to look at finding a particular solution here. So that was just the general solution. Okay, that's the general solution right there. Let's find a particular solution to this problem. So here's the initial condition. Y equals -9 when x equals 2. Y equals -9 when x equals 2. Yes, we're going to solve for c right here. Okay, now you have a choice. You could plug it into your final general solution, and that's fine. But I don't know about you, I really don't have to deal with the square root deal and everything. I'm actually going to go back up to this step. The y squared over 2 is equal to x squared plus c. The y squared over 2 is equal to x squared plus c. Or actually, wait, hang on. Yeah, I think that's okay. Y squared over 2 is equal to x squared plus c. I'm going back to that step, and I'm going to plug in my specifics. Okay, y is -9 when x is 2. So we've got 81 over 2 is equal to 4 plus c. So we have 81 over 2 minus 8 over 2 is equal to our c. So I think it's supposed to be 73 over 2 is our c. Now, when you find that c, I always want you to check it. Okay, so when you plug it in and you say that this is my solution, now, when it comes to these square roots, when you have an initial condition, you've got to decide, is it the positive square root or is it the negative square root? And it all depends on what that initial condition is. Based on this information, which one do you think it is? The positive or the negative square root? Negative. Because y is negative 9. The only way you're going to get a negative answer out of a square root is if there was a negative in front of the square root to start with. So after you say, this is my particular solution, I want you to check it. Plug in those numbers and make sure that it does work out. So 2 times 2 squared plus 73 over 2. And that's 8 plus 73 over 2. And that's not working out right. And this is why you check it.
I think you plugged something in before you take the integral.
I didn't. That was the step right after the integral. The y squared is equal to, yeah, that was the step right after the integral. Yes, Sam.
Why is it not 2?
Okay, I think that's where my problem is. I think that I need to plug it into the next step. Let's go back a couple of steps here. Instead of the y squared over 2, let's plug it into the next one where we had multiplied by the 2. Y squared is equal to 2x squared plus c sub 1. I think this is the better step. So we've got 81 is equal to 2 squared is 4 times 2 is 8. So we get just 73. I think that, yeah, that's right. Instead of 73 over 2, it should be just 73. So let's check it. Now, negative 9 is equal to 2 times 2 squared plus 73. That's going to work. Okay, negative 9, so 2 squared is 4, times 2 is 8. 8 plus 73 is 81. The square root of 81 is 9. I did that on purpose to show you the power of needing to check your answer when you get that particular solution. I really did. I knew the answer to that problem. Huh? I didn't get confused. Huh? What? I didn't lie. I really wanted to show you the power. You've got to check these particular solutions, okay? You really, really have to, because they love to do this scenario. I've seen this one a lot. With the square root, they like to use the negative situation. And a lot of people, when they take the square root, they just leave off the positive and negative, and they don't even consider the fact that you may need a negative in front of that square root. And they love to use a negative y. So if you don't have that negative in front of your square root, you're in trouble. You lose that point completely. Okay. They have these kinds of particular solutions. You have to do them on pre-response questions sometimes. I've also seen. Well, another reason why you need to check it is to make sure that your C value is right. Okay, make sure that your C is right. Now, we could have plugged it into the last one. You could plug it in any of these, except for that very first one. Y is divided by a constant. You need to go to the next step. Okay, so either one of these two steps, you can plug in your particular solution to get your C. Yes, sir. Well, I mean, technically I did multiply 2 by C, but 2 times a constant is just another constant. That's why I put that subscript right there. Okay, any other questions about these? I want to go back really quickly. Let's see here. to this scenario right here. I told you that you may need to do a U substitution depending on what's with that y. So let me do one really quickly that has the U substitution so you can see what I'm talking about. So let's say dy over dx is equal to negative 2y plus 1. Okay, let's do this one. So we still have to move everything like we did the last time. So we divide by the negative 2y plus 1 to get it on the dy side. We multiply the dx over. So we've got 1 dx. When we integrate both sides, integrating the right side, not a big deal. That's just x plus c, right? The left side technically is a U substitution problem. Now, it's a very simple situation of a U substitution, but it never hurts to look at it this way anyways. Technically, this is du over dy. The derivative of that is negative 2. We don't have negative 2 in the numerator of that expression, so we need to make that negative 1/2 du is equal to our dy. So technically, we're looking at this, negative 1 over 2 times the integral of 1 over u du. Negative 2y plus 1 was our u. dy is equivalent to negative 1/2 du. So we have negative 1/2 times the natural log of u, which I'm going to go ahead and plug in, negative 2y plus 1, is equal to x plus c. Before you put it in exponential form, you've got to move that 1/2 to the other side. So we need to multiply by negative 2. Negative 2x plus c sub 1. Negative 2 times c is another constant, so just rename it c sub 1. Now we can put it in exponential form. E to the negative 2x plus c sub 1 is equal to negative 2y plus 1. Go ahead and fix your exponential expression over there.
Thank you.
Okay, go ahead and put that c sub 1 in front. Technically, it's a different constant, so technically it's c sub 2. Because e to the c sub 1 would give you a different constant. Okay, solving for y, subtract the 1. And then divide the whole thing by negative 2. Something they may also do with this problem is split up this fraction. So put both expressions over negative 2. That would give us yet another constant in front. C sub 2 divided by negative 2 is a different constant. And negative 1 over negative 2 is 1/2. Okay. I'm just showing you that because I've seen them go in a bunch of different directions with these answers. So you need to recognize all the equivalent forms. Something else that I've seen them do, if we go back to this step right here, is sometimes they use properties of logs. Remember those back from pre-calc? We have a power rule that says if you have a constant in front, you can move it inside the logarithm to become a power. So instead of multiplying that constant to the other side, they may make that a power. Why is it what? Why is it not in the absolute value bars? Because right now the absolute value bars are kind of in place of parentheses. So it gets applied to that entire expression. So if we put this one in exponential form, we have e to the x, I'm going to go ahead and move my c to the front, is equal to, at this point, we can drop the absolute value. Now, if we're solving for y, we would raise this to the reciprocal power. So the -2 power, both sides raised to the -2 power. So c1 to the -2 is another constant. That's e to the -2x. Well, look, we're right back where we were. Same boat. So just two different ways of looking at it. You can use properties of logarithms, or you can just roll with it the other way, because we got the same thing right here. I use properties of logs. If there's a coefficient in front, it can become an exponent inside the log. And then I put an exponential form. I just skipped this step right here. I went ahead and went to putting the constant in front of the e, because that happens every single time. So I put the constant in front of e. And then I'm trying to solve for y. So I've got to raise it to the reciprocal power. Properties of exponents. Constant to the -2 is just another constant. And then power to the power is multiply. So it's e to the -2x. So then we're right back where we were with the other problem. So really, it's probably easier to look at it from the first perspective that I showed you. I just wanted to show you this in case you run into some problem where they're asking in what step was a mistake made, or what if they use the properties of logs instead of just multiplying that coefficient over. You got to know that it's the same process, so to speak.